Okay, so I just want to do a quick run through with the parabola. So the basic equation of a parabola is y equals x squared. And the basic shape for that is like that. So like a smiley face. When you put a minus in front, the effect of putting a minus in front is it will flip it upside down. If you put like a number, a constant outside the function, like you go plus 4, that will be a vertical shift, up 4. If you put down 4, that would be a vertical shift, down 4, like that. If you put a number inside the function, so inside the square, that would be a shift to the right, so that will go to the right, 2. So go to 2, and it'll go 2 to the right. Okay, and you should really get the y-intercept. If you put an x equals 0, you get 0 minus 2 squared. Minus 2 squared will give you 4, so it actually intersects at 4. And the same on this last one too. I didn't do the x-intercepts. See, if you put in y equals 0, the x-intercept would be 0 is x squared minus 4. So x minus 2, x plus 2, you end up with x is 2 and minus 2. Okay, so it's minus 2 and 2. So if you look at a combination of both of these, like if you had y equals x minus 1 squared, and then you went plus 3, that would be, that's going to be to the right 1, and it's going to be up 3. So if you went 1 to the right and you went up 3, that's where you would be. And if you look at that, if you put an x equals 0, you get 0 minus 1 squared plus 3. Minus 1 squared is 1 plus 3, so you end up with y-intercept is 4. In all your sketching, you've got to make sure you have the x-intercepts and the y-intercept as well. Okay, so that's just if you, okay, that would be just, if you did the shifting thing. If you then stuck a negative in front, so let's just go, y equals minus x plus 4 squared minus 1. So the effect of all these different things here is the minus would flip it and it makes it like a sad face, so it's going down. The plus 4 inside the bracket will be the opposite sign, so that would be left 4. And the minus 1 would mean it would go down 1. Okay, so basically it's going to go to the left 4, down to minus 1, which is there, and it's going to be a sad parabola. So if you put in x equals 0, you get y equals minus 0 plus 4 squared minus 1, y equals minus 16 minus 1, so y equals minus 17. So that y-intercept there would be minus 17. And just a couple of other concepts, like basically if you put a number in front of the x squared, like y equals 2x squared, the effect of that is that the y value is going to go up twice as fast. So normally, like when you've got y equals x squared, that's just like y equals x squared. Like when you put in x equals 1, y equals 1 squared, which is 1. But if you've got y equals 2x squared, if you put in 1, it's 2 times 1 squared, which is 2. So instead of going through 1, 1, which it would on that one, it's going to go through 1, 2. So it's going to go up heaps faster. So it's going to be steeper. Basically what we say is it dilates towards the y-axis, and it's a vertical dilation by a scale factor of 2. But we look at this later on in year 12. Okay, so say we have y equals a third x squared. The difference is when you have a number in front that is less than 1, then that's going to widen it, because instead of the y value being, say 3 times its original size, it is 1/3 of its original size. So that would be what your basic shape would look like there. So if you're looking at something like this, you've got minus, I'm going to go 1/2 x plus 4 squared minus 3. So there's a whole lot of things happening here. What do all these different numbers do? That one flips it. That one makes it wider. This one here shifts it left 4. And this one here, you go down 3. So you go down 3, left to 4, so that we're looking at here, flipping it and making it wider. So we're flipping it and making it wider. And if I put in x equals 0, I get minus 1/2, 0 plus 4 squared minus 3. So minus 1/2 times 16, which is 8, minus 3. That would give you minus 11. So it's going to go, I know the scale factor's not there very good, but it's going to go through minus 11.